In this video, I'm going to talk to you about dilutions. So when we add water to a solution of any kind, its concentration decreases. The solution is therefore being diluted, okay? So if you add water, volumes going up, concentrations going down, all right? And that's the premise behind this video. And performing dilutions, probably one of the most common lab skills that you'll be performing in the classroom, okay, is making dilutions, making stock solutions. So let's go ahead and look at this. We have, this is the same, it's just showing this inverse relationship. So we have our initial concentration multiplied by our initial volume equal to our final concentrations and volumes. Now, as long as you're consistent in your volume units and your concentration units, you can use whichever ones you want. For example, if you're using microliters, then you can use microliters as long as you use it for both parts of the equation. If you're using a percentage of a solution, or maybe an X strength, like a 50X solution for concentration, you can use it. So this is very handy. It is C1V1, C2V2 is what we refer to it in class. You may find it in the textbook or online as M1, V1, M2, V2, M for molarity. I use this because it's in biotechnology, we're using molarity, but we're also using, 500X fast blast stains and all kinds of different concentrations. And this works for all of them. We're going to go right into example problem number 1. Okay, so we have a 15 milliliter sample of 3 molar hydrochloric acid, and it was diluted by adding 10 milliliters of water. What is the new concentration of the hydrochloric acid? Remember, guys, if it's in brackets, that is the concentration. That's what it's showing. Okay, so I'm gonna always have both ways shown to you in class, in podcasts, and on your problem sets, so you're familiar with them all. All right, next step, lay out everything you know. You know concentration 1, that's what you're starting with. You know the volume you have initially. And what are you trying to find? Well, you're trying to find that final or new concentration. What's your final volume? 20 or 25, 15 plus 10. So just the thing with these problems is make sure your units, you're consistent, and watch and make sure of the wording and what your final volumes are and things like that. Then all you're going to do from there is use C1V1, C2V2, and plug in your values, algebraically rearrange and solve for concentration 2 in this case. And that's going to give you 1.8 molar solution. Okay, and you can see here the volume cancels out anyways, and so we end up with molarity. Some prefer to use moles over liters explicitly when using this. I'm good with just popping it in like so because it works just fine, okay? All right, so example number 2. Here we have a 35 milliliter sample of a 1.5 molar sulfuric acid, and it was diluted to 50 milliliters. What's the final concentration of the sulfuric acid? Okay, before you pause the video and try this yourself, I want to just give you a heads up. In the last problem, we added the 2 volumes because it said a certain volume was added. In this one, it's telling you it was diluted up to 50 mils. That's going to be your V2 for your equation. So pause it and give it a shot. Lay out what you know. In this case here, again, we're trying to find the final concentration. C1V2, C1V1, C2V2, and plugging in all of your numbers, algebraically rearranging this to solve for the final concentration of a 1.05 molar solution of sulfuric acid. So students typically find that these are not very difficult, but they are used most frequently in the classroom for lab skills. Okay, so here, you know, a little twist into this problem, and this is what many students will do for me in the classroom if I need help. So here, this student weighs out, you know, 0.25 grams of calcium nitrate, puts it into a volumetric flask very carefully, and adds distilled water up to 100, okay, after making sure it was dissolved and everything like we've talked about. Final volume, 100 mils, right up to that line on the volumetric flask. And then a 50 milliliter sample of that solution was then taken out and diluted to 75 milliliters. What is the final concentration? This problem looks harder than it is. It's actually very simple. All right. First things first, though, we need to get that mass into the moles so we can do some molarity computations. That's the first and foremost. So if you take your 0.25 grams of calcium nitrate and you convert it over, recognizing that there are 164.1 grams in 1 mole, that'll give you moles. Notice this ridiculous number of sig figs I've carried out. Remember, sometimes you carry out all or as many as you can and do your rounding at the end. This is one of those instances I want to be as accurate as possible. You remember we talked about this with the unknown metal molar mass stoichiometry problems as well. Okay, so I'm carrying all these digits out because I can. This is not my final answer yet, okay? Because I need to use this to find molarity. What is molarity? Moles liter. We have moles. Do we have a volume? Yes, we sure do. We have a volume. We know that there is 0.1 liters. Now, do please understand, like, at some point, you know, that's okay. I can live with that. At some point, just bump the decimal in your head. It's 100 mils. That's a tenth of a liter. Okay? Bump it 3 to the left. So that's what I've done here to save time in this video. All right, as you calculate this out, dividing moles by the liters, because that's what molarity is, you get a concentration of 0.015 molar calcium nitrate. Now what do? Well, now we can take this and use C1V1, C2V2 to calculate the dilution, okay? Because now we're diluting it even further, okay? So initially we have 50 mils. Remember, we took the 50 mils from the 100 mils. So our V1 is 50 milliliters. We're going to use 50 milliliters throughout. No worries. And our final volume is 75 mils. And we're asked, what is the final concentration? Okay, so algebraically solving this for C2, or the final concentration, gives an answer of 0.010 molar solution. Okay, and that should make sense. Okay, based on what we've done throughout this problem, we started with a molarity of the calcium nitrate. We took some of that out and we further diluted it, and our answer is more dilute, so this makes sense. Okay? All right, so final problem. Example 4, how many milliliters of a 5 molar copper 2 sulfate solution must be added to 160 mils of water to achieve a 0.3 molar copper 2 sulfate solution? Now, there's a little twist to this problem, okay? And it's right here. It's saying how many milliliters must be added to? Okay, so we're starting with a 5 molar and we're ending with a 0.3 molar, but it's saying how much of this, how much of that should be added to a given volume, 160. So it's an additive type problem. Okay, so if we lay this out, concentration 1, the concentrated 50, all right, the 5.0 is our starting, and we're ending with 0.3. So our volume 1, we don't know, okay? So we have to call it X, but we do know that we're adding that volume to 160 mils. And whatever 160 plus X equals is going to be our final volume, or V2 in C1V1. All right, so this problem is laid out like so. Okay, so we're going to need to use a tiny bit of algebra in this problem, okay, which sounds great to me. C1V1, laying it out as we usually do, it just looks a little different because we have this X factor here, okay? Now, what are we going to do algebraically? Distributive property, right? Distributive property, all right? Easy, okay? So if we use the distributive property of algebra, we get 5.0x is equal to 48 plus 0.3x. Now, subtracting 0.3x from both sides is what we're going to do next. And we're going to get 4.7x is equal to 48. So x equals 10.2 milliliters. Wow. Okay, so we need 10.2 milliliters of the 5.0 molar solution, and we're going to add that. So we're going to have a final volume of 170.2, and that should be 0.3 molar. I wonder how you can check your answer on this one. By popping it in. Popping it straight in and confirming. Is 0.03 molarity equal to this? All right, using C1V1, and now we have our final volume. By golly, it sure is. All right, so that's an affirmation, confirmation that you have done this problem correctly. Okay, so this is the closing here. We're just going to continue looking at molarity, dilutions, expressions, and solutions. I'll see you guys in class, and don't forget to work on this problem set when you have time. Thank you.